Okay, so here we are with lesson number 7, additional properties of lines. We're starting here at the top of page 54. Daily summary. In this lesson, we explore properties of horizontal, vertical, parallel, and perpendicular lines. Those are the 4 words for this lesson. This important note is the one that we just saw recently about replacing the word function with equation and replacing some funny looking symbols with a y. So when you see those in the My Math Lab homework, just come back to this little note here and make sure you're okay doing that translation in your head. Okay, number 1 says, consider these 3 points. First thing we're going to do is plot all 3 points. So take a moment right now to plot those 3 points. And if we were to connect those 3 points with a straight line, what word would you use to describe that straight line? Horizontal. So that's our answer to part B. The line connecting those 3 points is horizontal. Part C says write an equation for the line that passes through these points. Now in our previous lesson, we saw y equals mx plus b, and we saw that other one, the y minus y1 equation. We're not using any of that right now. We're just going to look at the coordinates of these 3 points and figure out what they all have in common. What's consistent for those 3 sets of numbers? 2. And which variable is represented by the 2? Is the y. So would you agree that the property that all 3 of those points share is that y is equal to 2? Super. That's the equation of that horizontal line. Every point on that blue line satisfies the property y equals 2. You agree? Not just the 3 points we plotted, but every point on that line satisfies y equals 2. So that's the equation. We don't have to think about mx plus b. We don't have to think about y minus y1. It's just what do they have in common. Let's go ahead and calculate the slope of this line. We can pick any 2 of our 3 points. Let's go ahead and use the first 2 points. So calculating slope, m equals, so I'm going to subtract. I'll do this order here. So upstairs, what are we putting? It is going to be 0. I'm going to write 2 minus 2. Downstairs. So according to my arrows, it's 7 minus negative 4, although if you wrote it in the other order, that's totally okay. Just be consistent. Upstairs is how much? That's a 0. Downstairs, for me, it's positive 11. For you, it might have been negative 11. How much is 0 divided by 11? It is 0. It's a perfectly good number. That number is 0. So the slope of this line is 0. And in fact, are you willing to buy that the slope of every horizontal line is 0? Because if you are on a horizontal line, then what we just saw was that the y values are going to be consistent, yeah? Might not be 2's, but they'll all be the same. And so then when it comes to this part, where up on the top of the slope, you find the change in y, you're going to be subtracting the same number from itself, right? Might not be 2's, but it's going to be the same number. So in that fraction for the slope, always going to be a 0 up on top. And 0 divided by any number is 0. So the slope of every horizontal line is the same as the slope of that one. It's 0. Okay, let's take a look at number 2. Consider these 3 points. First thing we're going to do is plot all 3 points. Take a moment. And then go ahead and draw a straight line connecting those 3 points. And in part B, so what word would you use to describe the line that connects those points? Vertical. This is one of my pet peeves. A lot of people misspell vertical in the last 2 letters. How do we spell it? It's A-L. A-L. Look, I'm never going to take points off if you misspell a word, but it is going to hurt me a little bit inside if you misspell it. I know. All right, so that's vertical. Another one that drives me nuts is nickel. A lot of people misspell, they swap the last 2 letters in nickel. All right, let's write an equation. Forget mx plus b, forget y minus y1. Just look at the three sets of numbers. What do they have in common? Which value is 4? X. X equals 4 is the equation of that line. And every point on that blue line satisfies the condition that x is equal to 4. Let's calculate the slope. Again, you can choose any two of the 3 points. Let's pick the first two. We'll subtract in this order. Just be consistent when you do your calculation. M equals, okay. So according to my order, what minus what upstairs? 2 minus 5 upstairs. Downstairs? 4 minus 4. Up on top, I have a -3. If you had +3, that's A-okay. Downstairs? 0. What is -3 divided by 0? It is undefined. It is not 0. We have been taught from a very young age that you cannot divide by 0. Yes? Something that was drilled into you pretty soon after you started to learn how to divide numbers. You cannot divide by 0. And it is still true. And so the slope here is undefined. That is the answer. It's a perfectly legitimate answer. The slope just happens to not be a number. Slope is undefined. And in fact, the slope of every vertical line is undefined. It's the same reasoning that we talked about for the horizontal lines having a slope of 0. If you are a vertical line, then you're going to have consistent x's, right? They might not all be 4s, but they will all be the same number. And when you do the slope calculation, change in y on top, change in x on the bottom is going to be 0 because you're going to be subtracting 2 copies of the same number. Doesn't have to be 4, but they'll be the same. And so every vertical line, you're going to have a division by 0 on that slope calculation. And so every vertical line has undefined slope. Now, some people will look at that and say, oh, -3 divided by 0 doesn't exist, and so it has no slope. I'm going to take points off if you say that this has no slope. And I hope this isn't me being nitpicky. I think I'm justified here. If I say I have no oranges, how many oranges do I have? 0, yes? So commonly in the English language, no means none. I have no oranges. So if you say it has no slope, then I am hearing it has 0 slope, and that is not right. This is an undefined slope. Undefined or not defined are the only acceptable answers to the slope of a vertical line. Not defined or undefined. Okay, here are the big conclusions. These 4 sentences down here at the bottom represent everything I need you to know about horizontal and vertical lines. The equation for a horizontal line has the form y equals some number. It was like the first example that we did. Every horizontal line is y equals some number. The slope of every horizontal line is 0. We justified that up above. The equation for a vertical line has the form x equals some number, like this guy, x equals 4. The slope of every vertical line is undefined. Those 4 sentences, I feel, should really go on your reference sheet when you make your reference sheet for the upcoming test or quest. It's everything you need to know. And I want to highlight that you really actually do need to know this stuff. You can't just make it all up on the fly. Because so y equals mx plus b is the equation most of us are going to be using this semester as our default. If you tried to use y equals mx plus b for this vertical line problem, what do I change the slope into? This m. What's it going to become? It's undefined. This equation is only good if I can plug a number in for m. So y equals mx plus b just flat out doesn't work if you have a vertical line. There's no way to use y equals mx plus b for vertical lines. And so if I'm asking you to go out of your way to just memorize the bottom 2 sentences here as just being something special for vertical lines, well, why don't we just treat horizontal lines the same way? Turns out you could use mx plus b for horizontal, but I'm willing to just say horizontal and vertical are special cases. They're independent of mx plus b. It's just those 4 facts. Okay, next page. It says, here's the thought process for finding equations of horizontal and vertical lines. What we're going to do is find the line that has undefined slope and passes through the point 5, -7. That is a typical homework question, typical test question. Find the equation of a line that has undefined slope and passes through 5, -7. So first thing that we tip off on is that it says undefined slope. What kind of a special line did we just discover has an undefined slope? Which one? Vertical. So that first thing, this is all written in the paragraph, but I'm just going to write our thoughts up here instead. Undefined slope immediately translates to the word vertical. The word vertical immediately translates to either y equals a number or x equals a number. Just look on the previous page if you don't remember. Vertical, is it y equals a number or x equals a number? It's x. I'm just going to write it informally like that. X equals some number. We're almost there. All we need to do is figure out what number x is equal to at the only point we're given, which is in green. How much is x at that point? It's 5. X equals 5 is the final answer to this problem. That's the equation of the line that satisfies those conditions. What piece of info in this given problem was completely irrelevant to us? The -7. We could care less. It made no difference at all. That wasn't the thing that was important about that point. It was the x. Okay, so here's a similar one in number 5. Find the equation of the line that has m equals 0 and passes through 3, 2. So let's play the same game in terms of translating. M equals 0, that's one of our two special ones. Which one is it? That's horizontal. Horizontal lines always have a special form for their equation. Is it x equals a number or y equals a number? It's y equals. If you don't remember, you just go look on the previous page and write that on your reference sheet. So all we care about is how much is y at the one point we're given. What number is y? 2. Y equals 2 is the answer. These questions are going to show up on the next quest and on the first test. And they're really easy as long as you can follow this little detective process that we follow. But it's also easy to get it wrong because some people put y equals 3, and that isn't it. And some people put x equals 3, which also isn't it. And some people put x equals 2, which isn't it. And some people are going to put like y equals like 3x plus 2 or something. I mean, desperately trying to use the mx plus b equation. There's a lot of wrong answers. Like, we make it look very easy up here. There's a lot of wrong answers to this problem that I see over and over again. So just make sure you're comfortable with the little detective game that you got to play. You'll get it right every time, pretty quickly too. Number 6. The 3 lines graphed at right, these 3 diagonal lines, appear to be parallel. What does parallel mean? That's going to be our conclusion. Thanks for spoiling it. What does parallel mean? They are the same distance apart, and they never touch each other, right? They stay consistent distance apart as opposed to intersecting lines. Okay, so it looks like those are parallel lines. Let's have a look at their equations, which are written up here. Y equals 2x plus 4, y equals 2x minus 1, and y equals 2x minus 8. What is the same in those equations? The slope, right? And we know that the mx plus b business tells you that the slope is the number touching x. How much is the slope for all 3 lines? It's 2. So here's our conclusion. And Evan, go ahead and read number 7 for us. Said it before. Evan, can you read 7 out loud?
Oh. 2 lines are parallel, but the slopes are...
Yeah, if the 2 slopes of lines are equal, then the lines are parallel. Okay? That's the only thing I need you to know about parallel lines. It's a tougher relationship for perpendicular lines. So taking a look at number 8, we've got 2 diagonal lines that are graphed here. What does it mean to say that they're perpendicular to each other? They do cross each other at 90-degree angles, right? They don't just intersect willy-nilly, they intersect at right angles or 90-degree angles, right? Right. And so what we're going to do is we're going to find the slopes of these 2 lines right here. So how about we do this together real quick? I'm having a hard time because my graph is not as clear. Can you guys see the background grid a little better than I can up here? So what I'm looking for are points that I can grab the coordinates of, like nice coordinates. So for example, like this point right over here, what are the coordinates of that point? -4, everybody buy that? And do you see why I pick that point and not, for example, this red point right here? What's difficult about that red point? It's not on the background grid, right? So I can tell you that x is 4, but the y is like -3.8, and I don't want to be guessing here. I want to get something exact if possible. So is there another point? I'm having a hard time seeing it here. 0, 0, 4 on the other line? Okay, so we'll do that guy. 0, 4 up there. 0, -3 on the bottom one here. Okay. Good. We need 2 points on each line. Can somebody find a nice point on another nice point? -1, -1. Do folks agree? I can't tell. Okay, so we've got 2 points for 2 lines. These 3 tables that I'm pointing to right here, you're going to find the slope of the red line back there. Other 3 tables, you're going to find the slope of the blue line, and we'll just report back in a minute. Find the slope of the blue line up here in the front. Okay, so we've discovered the slopes of these 2 perpendicular lines are 5 and -1/5. I'm going to write that 5 as 5 over 1, which normally I would ask you never to put an over 1. But there's a relationship here between these 2 slopes. What's the relationship? Reciprocal, fancy word for flip the fraction over. And the other piece, 1 is positive and 1 is negative. And that's crucial. Think about the fact that you have 2 lines that are perpendicular. This guy right here is going uphill from your perspective, right? And any line going uphill has a positive slope. But if this line is going uphill, what can you say about that perpendicular line? Has to be going downhill, right? No matter how I make these 2 lines, as long as I keep them perpendicular, one is uphill and one is downhill. And uphill has a positive slope and downhill has a negative slope. There's only one exception to this uphill downhill, and that's our special horizontal and vertical, which we've already talked about. So as long as we're not in that special case, one line is positive slope, the other is negative slope. So here's our conclusion, number 9. If 2 lines are perpendicular and not vertical, that's me getting rid of the special case, then the slope of one line is the opposite reciprocal. 2 pieces. Opposite means change the sign. Reciprocal means flip the fraction. So you are going to get practice in the activity. And so just in the interest of making sure that you have a chance to practice with the new stuff, I'm going to ask you to not start at number 1, but rather, I'm going to circle the ones that I want you to do. We're going to do 4 and 5 and 6, 7, 9, 10. 4, 5, 6, 7, 9, 10. Let's see how many of those we can do. 4, 5, 6, 7, 9, 10.